7.2 Translations. Under a translation, every point is moved by the same amount in the same direction. If each point moves A units in the X direction and B units in the Y direction, we use vector notation like we see here to describe this translation. So A in this part would represent movement in the X direction, and B right here represents movement in the Y direction. So this is easier to see with an example. So if we have 4 and 2, here's the vector. This represents a translation, and what it represents is 4 in the X direction and 2 in the Y direction, and that occurs to every point on the image or figure. So here we have this flag, and so if we take the bottom point then apply this vector, that means that 4 moves it 1, 2, 3, 4 units in the X direction, and the 2 means that it moves 1, 2 units in the Y direction to find the bottom of that flag moved over to here. And so this translation applies to every point along this flag. So if we took this one here, it would go over 1, 2, 3, 4, up 1, 2, and it would end up over here. And it's the same for this point, it's the same for this point, it's the same for this point, 1, 2, 3, 4, 1, 2. So this is movement in the X direction, or translation in the X direction, and this is movement or translation in the Y direction. So let's look at an example here. And so example 1, draw the square with corners at the points with coordinates 4, 0, 1, 3, 4, 6, and 7, 3. So remember that that's in the form x, y. Okay, so the number on the right is x, and the number on the left, is x, and the number on the right is y. Okay, so first let's put those values onto this graph. 4, 0, 1, 3, 4, 0, 1, 3, 4, 6, and 7, 3. So we can join these points together to make the square that we're starting with, and then we're going to apply a vector to make a translation on this shape. The squares translate along the vector 5, 2. Draw the new square obtained by the translation. Okay, so we'll draw the new one in red. So we're going 5 and 2. That means 5 in the X direction and 2 in the Y direction. So let's take the furthest point over here. So we're going to move over 5. 1, 2, 3, 4, 5, and then we're going to move up 2. 1, 2. Okay, so this point of the square gets translated over to this point. If we take this one, we move over 1, 2, 3, 4, 5, and then we move up 2. If we take the leftmost point, move over 1, 2, 3, 4, 5, and then up 2, and then finally the top one, 1, 2, 3, 4, 5, and then up 2. And so now we can join these dots, and we get our translated square after a vector of 5 and 2. So that means that every point on this square has moved 5 units in the X direction and 2 units in the Y direction. A second example, the diagram below shows the shapes A, B, C, and D. Along what vector would you translate? And then we have a bunch of different options here for going from one to the other. So that just fits in. Okay, so how do we go from D to A? Okay, so how do we get from starting here to getting over to here? Well, we simply count the units in the X and the Y direction. Okay, so to get from D to A, we have to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units in the X direction, and then 1, 2, 3 units in the A direction. So that means if we were to write a vector for that, for part A, to go from D to A, we would have 10 units in the X direction and 3 units in the Y direction. So that would be the vector and solution to A. Now if we look at B, we want to go from C to D. Okay, so we want to go from C to D. Okay, so we're starting down here and we're moving up to here. Alright, so we go right just 1, and and we go up 1, 2, 3, 4, 5, 6, 7, 8. So the solution for B is we're going 1 in the x direction and 8 in the y direction. Okay, let's do another one. C, we're going to go from A to B. So a fair amount of movement. We're going from A over to B. So A, in the x direction, we go 1, 2, 3, 4, 5 units in the x direction, and now we're going down in the y direction, and so that is going to be represented by a negative number. Okay, so we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's negative 10 in the y direction, and we moved 1, 2, 3, 4, 5 units in the x direction. So if we go down, it's negative. If we go up, it's positive, and that's for the y direction. In the x direction, if we go right, it's positive. If we go left, well then it would also be negative. So how do we go from A to C? And that will be an example of us doing negative in the x direction. So to go from A to C, we go to the right how many points? To the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units to the left in the x direction. So that means that our vector is going to be negative 11 in the x direction. And then we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units as well. And so that will be represented by negative 11 for the y direction. So we went negative x and negative y, and we ended up going left and down. And there we have it.